Okay, so we are doing section 2 of chapter 2, basic differentiation rules and rate of change. It will be split into 2 sections, so you'll do the beginning, part 1, today, Monday, and then you'll do the other part on Wednesday. All homework will be due on Friday for both of those sections. Okay, all right, so first thing we have is constant rule. All right, it says the derivative. So derivative is our concept that we talked about. We did definition of the derivative last week, okay, and we had to do that long limit as x approaches, as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. That's the definition of derivative. You're going to learn some shortcuts today. All right, so the derivative of a constant is 0. That is, if c is a real number, then the derivative d over dx is a way to write derivative. So just a side note, d over dx of a function f of x is the same thing as f prime of x. Another way it can be written is the derivative with respect to x of f of x. Just different ways of writing the same thing. So just make sure you remember that. All right, so the derivative of a constant is always 0. So the derivative of 1 is 0, the derivative of 2 is 0. So if we go through some of these examples, okay, part A, if we're trying to find the derivative of y, you would actually write that dy over dx. It's the derivative of y with respect to x. Okay, think of change in y over change in x, delta y over delta x, dy over dx. That's how those kind of correlate. And based off the fact that 7 is a constant, the derivative of that is 0. F of x equals 0. You would write that as f prime of x. 0 is a constant, so the derivative of a constant is 0. S of t, you would write as s prime of t. And negative 3 is a constant, so that would be 0. So k is a constant and pi squared is a constant. So you actually have a constant times a constant. Okay? And so that is still, this whole thing would then be a constant. Because remember, pi is a number. Pi squared then is a bigger number, and times k, it's still a number. So our dy over dx, another notation is y prime. I know there's a lot of different ways to write it. That's because several mathematicians develop derivatives and have their own notation for it. So they're going to be used interchangeably. So that's probably one of the harder things about this is recognizing some of the notations. But the first derivative of y is still going to be 0. All right. Okay, so then the power rule. So what if it's not a constant? Okay, so this rule looks crazy. If n is a rational number, rational meaning can be written as a fraction, then f of x equals x to the n, so your exponent is a rational number, is differentiable, meaning I can take the derivative of it. Then d over dx of x to the n power, that reads the derivative of x to the n power, is equal to nx to the n minus 1. So what has happened is, if this is our function, you will take the exponent and you will multiply it in front. So I will have nx, and then you'll subtract 1 from that exponent always. So that's where that rule comes from. So if we look at that as an example, okay, f prime of x, ignore that equal sign, f prime of x is equal to, I'm going to bring my exponent down like that and multiply it. And then my exponent has to decrease by 1. You don't have to write that step, but I want you to see it, so that I have 3x squared. If you were to do your limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x with this function, you would get 3x squared. Okay, so that is the shortcut for it. So you should be able to check, if you haven't finished your homework from section 1, you can check all your homework from section 1 by doing the shortcut on most of them. Now, you won't know the shortcuts for all the different ways it can be written, but you'll know some of the shortcuts. Okay, by the end of the chapter, you'll know most of them. All right, so one thing about this is I would rewrite this as x to 1/3. Keep in mind that roots are rational exponents, so you can just, square root is a power of 1/2, a cube root is a power of 1/3, so on and so forth. So then I can say that g prime of x is equal to, I take my exponent, multiply it down in front, and then I will subtract 1 from my exponent and simplify. So I have 1/3 x to the negative 2/3. Do not leave negative exponents where they are. Okay, you're going to have to manipulate it. So 3 is in the denominator with the x to the 2/3. Okay. All right, and last one, you can call it y prime or dy over dx. This one would be easier to rewrite as well, x to the negative 2. Okay, let me scoot this guy over a little bit. So y prime is equal to, multiply my exponent down in front, x to the negative 2 minus 1, negative 2x to the negative 3 is equal to negative 2 over x cubed. Okay. If you're confused about some of those simplifications, you probably need to go back and review power rules that you've done previous years over time, but that we did review in Chapter 1 or Chapter P. Okay. Oop, too far. Find the slope of a graph. So this is important to remember that slope is the same thing as your derivative. Okay. So I'll abbreviate that, derivative. Okay. All right. So for f of x equals x to the 4th power. So last chapter, you would have had to do the long way and then go plug in these numbers. This chapter, or this section, we can subtract. So that's our derivative. And all I have to do is go plug in negative 1, plug in 0, and plug in 1. Okay, so instead of doing the really, really, really long difference quotient here, I can just use my power rule and go in and plug. So A, not an at, an A would be f prime of negative 1. So 4 times negative 1 cubed. So we get negative 4. Okay, so no problem there. All right, and then we can do B. F prime of 0 is equal to 4 times 0 cubed, which is 0. And C, F prime of 1 is equal to 4, 1 cubed, which is 4. And you can actually see they drew them in blue. At negative 1, you had a slope of negative 4. You had a 0 slope. 0 slopes are horizontal. So if they ever say, find the value that makes a slope horizontal, you're going to be looking at what makes a slope 0. Okay? Or vertical would be undefined. You'd be looking at what makes it undefined. Okay? All right. So those are your 3 answers for that problem. All right. The constant multiple rules. So that's kind of combining concepts. So you have your power rule, but all those powers, if you notice all the ones we had on the previous problems, they all had leading coefficients of 1. But what if it's multiplied by a constant, say 2 or 3? So if we look at this rule, it's actually really simple. If it's multiplied by a constant, then the derivative is just multiplied by a constant. So I think this is easiest done by doing some examples. So if you kind of see the constant times f of x is the constant times f prime of x, the derivative of that. So if we do the derivative of y with respect to x on this case, I'm going to have my 5, leave it where it is, times, it's already multiplied to x cubed, so it's staying multiplied. Okay, but I'm going to take the derivative of x cubed. So 3 down in front, subtract 1 from the exponent, and then you simplify. Okay. So then we can do the first derivative of y. Okay, I'm going to rewrite this as 2x to the negative 1, so that'll be easier to simplify. And I'm going to have 2 times negative 1, I'll put that in parentheses, x, subtract 1 from the exponent, negative 2. I can simplify that to negative 2 all over x squared. Remember that your negative exponents must go below. The 2 and the negative 1 both have positive exponents, so you don't really have to worry about that. Okay. All right, this one. Your constant in this case is, let's call it f prime of t. Your constant is 4/5. So I'll have 4/5 times. I'm going to take my 2, bring it down in front, and subtract 1 from exponent. You don't have to write that 1. So I do need to simplify it. Remember, when you multiply fractions, it's top times top, bottom times bottom, So I have this. Okay, I'm going to rewrite this as to the power of 1/2. So dy over dx is equal to 2 times the exponent 1/2. Subtract 1 from 1/2 until negative 1/2. And then I'm going to simplify it. 2 times 1/2 is just 1. So I will have 1 over x to 1/2. Or, and you can leave it like that, or I can have 1 over root x. You can write it as a square root again if you want. So it doesn't matter which time. All right, this one, I'm going to rewrite it first. So I have my 1/2, the 1 over 2, and then that is a cube root of x squared down in the denominator, so it is going to have a negative exponent. And if you remember, roots give you the bottom of the fraction, and then the exponent is the top of the fraction, so that's the same equivalent thing. But y prime is equal to 1/2 times negative 2/3. Put my negative multiplications into parentheses. Helps me make sure I don't make silly mistakes. And then x to the negative 2/3 minus 1. So negative 2/3 minus 3/3. So negative 5/3. Okay. And then what I can do from there is simplify. If you notice, I have a 2 on top here and a 2 on bottom here. So that'll simplify. I like to simplify before I multiply. You don't have to do that. I think sometimes it does make it a little bit easier. And you can leave it like this if you would like. Or, and I really would on that one since it's not like a super common thing, but you could put it back as a cube root if you wanted to. That's up to you. I honestly would leave it here if it were me, but it doesn't matter. It's fine either way. Back to this simplification, sometimes that confuses people. If you don't like to simplify for multiply, by all means, multiply straight across, negative 2 over 6. It'll reduce to negative 1/3. You get the same thing. All right, so this one I'm going to rewrite, or not rewrite, actually. I'll just do the derivative of y with respect to x is equal to my fraction times, bring my exponent down, and now it's going to have an exponent of 0. Anything with a power of 0 is 1. So this whole thing is actually 1, so it's just negative 3/2. Okay. Anytime you're doing the derivative of a linear function, it's just going to be your leading coefficient because you have a power of 0. That takes practice to get used to. The more you do it, the better you'll get, but those will help you check some of those. So when you get this test, and I'll be back by the time we take this test, so we'll be able to review in depth. But when I ask for the definition of derivative, you have to do the long way, but there's no excuse to miss it because you should be able to check your answers. Now you have to have correct work, but you'll know to go back and fix things. All right, so this is a combination of things. So if I'm going to add things I can take the derivative, then I can take the derivative of this whole thing. So f prime of x is, and we'll just do section by section. So the derivative of x cubed is put the exponent down in front, subtract 1 from the exponent. The derivative of minus 4x is minus 4, and it's x to the 0. If you want to write it, you can, but it's just 1. So I'm just going to leave minus 4. And then the derivative of a constant is just 0. So this is my answer. All right, we can go again. All right, so I'm going to have negative 1/2 times 4x cubed, because I got to subtract 1 from the exponent, bring the exponent down, plus 3 times 3x squared minus 2, because x to the 0 power is 1. And I'll just simplify that there. And you don't have to show all these steps. The better you practice this, the better you'll get at it. So when I see this, I just see 4. I'll look at just this, and I automatically see 4 times negative 1/2, and I'll automatically go to my 2x cubed. I don't even do that. I will automatically see 3 times 3, and I will get